Hello and welcome. Let's try to solve another Leetcode problem. 2498 block jump 2. So we are giving a zero indexed integer array stiles, and inside the stiles array, it's going to be the positions. It's going to be strictly in increasing array. So for example, 0, 2, 5, 6, and 7. So this is going to be the meaning of the positions of the stiles. And there is a frog. It can jump forward and backward. So we're going to return the cost of a pass for the frog. So we're going to check the minimum cost. So what is the meaning of the minimum cost? Let's just try to make a drawing. So if we have some positions, so for example, let me use another color. Yeah, so we have some positions like 0, 2, 5, 6, and 7. So 0 gonna be the first stile, and 7 gonna be the last stile. So this gonna be the last stile. And we want to return the minimum cost of a pass. So if we just jump from the first to the last and go back from the last to the first, so what is the cost? So it's gonna be 7. Yeah, but the greedy idea is that why not we just use other stiles? Why not we just use all the stiles? Because if we use more stiles, it's a high probability that we're gonna get a smaller value, definitely. Yeah, and my intuition for solving this problem is that for this frog jump, yeah, definitely I remember 3 years ago while we are learning the greedy algorithm in university, and definitely yeah, we used the frog jump as an example. Maybe it's not the same. Maybe we used to just go forward. We didn't go backward. And for this problem, go forward and backward. And my second intuition is that while I'm checking this length of the stiles, it is 10 to the power of 5. Yeah, this means basically we're going to use n or log n to solve the problem. Yeah, I'm considering also about the dynamic programming, but that might be too hard because there are so many different cases. It's like brute force. Definitely it's not possible. Then because it is 10 to the power of 5 of the array, then I'm thinking about maybe we can use a greedy idea. So all those positions is sorted. Maybe we can use a greedy ideas to calculate the distance directly. And the greedy idea is that in order to make the minimum cost for a pass go forward and backward, so why not we use all the stiles? So if we were to use all the stiles, how are we gonna use all the stiles? So we're just gonna ignore the first and the last. We're gonna focus the problem in the middle. Yeah, so if it is in the middle, we're gonna focus on those 3 numbers. Maybe there are more numbers, but we will ignore first and last because definitely we will jump at the first position. We're gonna jump to the last at some positions, and from the last we're gonna jump to some positions and go to the first. Yeah, because definitely we're gonna use the first and the last 2 times, or maybe you can think many times from first to last, last to first. We can jump many times, but it doesn't matter. But yeah, so at least first we're gonna use 2 times. You can say 0 to this 7 position, and then at 7 to 0. Definitely we use the 2 times, but it doesn't matter for the first and last. We're gonna focus the problem in the middle. Yeah, so in the middle, how are we gonna check this problem? Can we just use 2 and 5? We jump from 0 to 2 and to 5, and then to 7 directly. And another case is 7 to 6, and go backward to 0. Yeah, and this is the optimal way to solve the problem. Yeah, we just consider this problem. As you can see, we can jump from 0, 5, and 7. Another way is to go backward 7, 6, and 0. And we found that it is not the best way to solve the problem. Yeah, so if we can jump, why not we leave some space for the backward jump? So for example, we're gonna jump from 0 to 2 to 6. Why not jump like this? This is better. For 0 to 2 and to 6. And go backward 7, gonna go 5 and go 0. And then we can calculate what is the minimum. Yeah, what is the minimum cost. So the minimum cost is the maximum of all the distance, like 0 to 2, 2 to 6, and 6 to 7. at 7 to 5, 5 to 0. So it's gonna be 5 in this way. I think this is the optimal way. And another way is here. As you can see from here, the distance is 2, 3, okay, 2, okay, but here is 1, distance is 6. So the maximum is 6. It means this is not the optimal way to solve the problem. Yeah. So the first intuition is that we're gonna use the stew as much as possible. So in the middle, we're gonna use all the stews. This is the first intuition. The second intuition is that we're gonna leave some space for the backward jump. For the forward jump, we're gonna choose some stews, but we will leave some space. So the intuition is that for the forward jump, we're gonna choose the even numbers, even index. For example, this is index 0, 1, and 2. We're gonna choose the index 0 and 2. For the backward jump, we're gonna choose the odd index. And in this way, it's gonna be the optimal solution. Or for the forward jump, we're gonna choose the odd, and for the backward, we're gonna choose the even. But the result is gonna be the same. Yeah. Another idea is that, so what if we just don't use this 5? So this is the first intuition. We're gonna use as much as possible. Yeah. So this is no better than we just use this 5. Maybe for the forward, we can use this 5 and go somewhere. Yeah. We're gonna use the stews as much as possible in the middle. And another intuition is we're gonna use even and odd to jump. The first round forward, we're gonna use even, and backward, we're gonna use odd. And then we're gonna calculate the maximum of all the distance. Yeah. Now the problem becomes easier. So let's prepare a first stew and a last stew. It's gonna be the stews 0 and the stews -1. Because the length of the stew is at least 2, and we can check it from here, it is at least 2, so definitely we're gonna have a first and a last. Yeah. Now what about the middle? So in the middle, we're gonna have an array. So it's gonna be the stews from 1 to -1. This means the stews in the middle. Then we're gonna prepare a forward array. So let's write a forward. Forward should equal to the first plus the middle plus the last. So it's gonna build a new array. This is preparing for the forward. And then we're gonna prepare a backward. This means go back. Definitely we're gonna use this first, and we're gonna plus a middle. It's the same, right? No, it's not the same, but let's just use the middle and plus the last. It's not the same. Now we're gonna change something about the middle. So for the forward, we're gonna use the even index. So we're gonna use the even index. It's gonna be with 2. Yeah. So for the odd, we're gonna use the dot with 2, but we're gonna start from index 1, and this is just to start from index 0. So this is for the even index in the middle. This is the odd index for the middle. This means definitely we used all the stews. Yeah, this one plus this one. This means all the stews in the middle we used, and we used the even index and odd index because this is gonna be the optimal way. Yeah. So finally, we're gonna return the maximum of the distance 1 and the distance 2. So we're gonna calculate the distance 1. It is for the forward array. So it's gonna be the maximum of let's use forward. So forward I minus forward I minus 1. So for I in range length of forward, right? And also for the backward, we're gonna calculate a distance 2. It's gonna be the maximum of the backward I. Similarly, yeah, minus backward I minus 1. So for I in range length backward, yeah. But we need to start from index 1 because we use the I minus 1, and here also the same from index 1 to the length of the backward array. Yeah, so this is going to be the entire code. As you can see, it's not so difficult. Basically, it's the greedy idea. I mean, we don't need to get a formula about it. And basically, we're going to use some intuitions. And by these intuitions, we just need to prove a little bit this is going to be the optimum solution, because we cannot find a better way than that. Yeah, if we are not doing that, as I explained earlier, definitely it's going to have a bigger value. Now, this is the smallest value, so this is the optimal way. Now let me run it to check. As you can see, it works. Now let me submit it to check if it can pass all testing cases. As you can see, it's pretty fast, and it passed all testing cases, and the time complexity is ON, and the space complexity is also ON, because we never used sort for this problem. We just take out the even and odd. Yeah. Thank you for watching. See you next time.